Hello, good morning, guys.
Good morning, sir.
Good
Very good
morning, sir.
morning. Very good morning. Good morning, Ira. Everyone, good morning. Yes, good morning, Edric. Good morning, David. Yes, good morning, Miracle. Everyone, good morning. Turn on the camera, please. Okay, so what chapter we were doing? We were doing chapter number 27. Let me take out the chapter. Yes, we have chapter in front of us. I mean, this, what we were doing? I guess we were in ore. Yes, we were in the ore part.
Sir,
So, yes.
do you remember in our last in the last class we went
Hmm.
your screen shut down before we could finish writing.
Yes.
When I tried to find a video in the channel, I cannot find it. The latest videos is shown. The latest when I press latest videos in your channel, they're
Hmm.
showing like 1 year ago made videos, not the
No,
latest
no.
one.
Video won't be there in the live. When you will go in the live part, if you will go to the video means what we upload, it's called as video. There is another column near the video only, it's called as live. So live, every day you have to go to the live part. In that live, you will find it out. In the live, you will find it out, not in the video part.
Okay,
So,
sir.
yes, we learn about the thermite process also. So, for a brief point of view, thermite process, the process. Agatha, what is thermite process? What is the meaning of thermite process, Agatha?
The displacement the displacement action of the metals.
Like specific in which way? Like the thermite reaction helps us to repair the railway tracks.
Ah, yeah,
Okay,
right.
in the railway tracks. So we have this thing. Now we will learn about the reaction of non-metal with the help of reaction of non-metal with the help of oxygen. So, uh, non-metal, non-metal with oxygen. A part. Everyone, turn on your camera, please. David, Edric, Miraculin, turn on your camera, please. Okay. So, whenever a non-metal, everyone, please pay attention. Whenever a non-metal reacted with oxygen, it always give non-metal oxide. Which oxide, beta? Non-metal oxide. Okay, remember this. So we learn this whenever metal react with oxide is called as metal oxide, correct? And whenever non-metal react with it, it is called as non-metal oxide. What oxide? Non-metal oxide. And we discussed this in the acid base and salt one also, that non-metal oxide generally they are acidic in nature. They are acidic in nature. Who? Non-metal oxide. Non-metal oxide, basically they are acidic in nature. Okay, they are acidic in nature. So, like for example, if I will take one example, like carbon plus oxygen give carbon dioxide. Okay, now carbon is non-metal, oxygen is like oxygen is oxygen. It give carbon dioxide. Nobody is dying, but it is called as carbon dioxide. Carbon dioxide. Everyone got it? Yes or no? Okay. In the same way, we have this thing. Sometimes it forms neutral also. Like we can check that here. This nitrous oxide. Okay, nitrous oxide, which is called as neutral in nature. Okay, it is neutral in nature. Nitric oxide, which is also neutral in nature. But dinitrogen trioxide is this acidic in nature. So sometimes it's neutral also, but generally they
Yeah.
are in nature. Yes,
Is carbon dioxide acidic?
carbon dioxide acidic. Yeah. Okay. We carbon dioxide. I guess it's H2CO3. Carbon dioxide. Let me check. It's acidic, I guess. Acidic. Yes. Correct. Okay. It's acidic in nature. So you guys can see that nitrogen dioxide, dinitrogen tetraoxide, or dinitrogen pentaoxide. These all are acidic also. So what is the nature of non-metal oxide? Nature of non-metal oxide is whenever they dissolve in water, we get acidic. So like SO3 is non-metal oxide, dissolve in water, become hydrogen sulfuric acid. N2O5, when dissolved in water, we got HNO3. So we can conclude that due to their acidic nature, many non-metal oxides directly react with bases to give salt. So we learned that whenever acid react with base, it gives salt. Now this all are non-metal oxide, and non-metal oxide when react with base, it gives salt and water. Hence, these are in acidic in nature. Acidic in nature. Got it, everyone? Yes, Agatha.
So when a non-met, so why does nitrous oxide or laughing gas is neutral and nitric oxide is basic?
That's why
Loss.
I'm saying it's generally when non-metal oxygen is formed or non-metal oxide is formed, it's acidic. Not always. Generally, it's make this thing. Got it?
Got it.
Write it down quickly, everyone.
अरे यार. Wait. So after finishing this chapter, will you start math again or no?
No, no.
So you finish this chapter and next chapter, and then you'll start math again.
Yeah, maybe.
So, is there anything in
Yes.
science other than chemistry remaining?
What?
Other than chemistry, are we going to do anything else in science?
There's
Bio.
also hereditary, that is biology.
Bio is there. 3 chapters is there. Then and physics.
No more physics, right?
Physics 1 chapter is still there.
I like physics, but I do not like chemistry.
After this, we'll do one more chemistry chapter. Then I guess chemistry will be completed after doing this.
Then
And it
after
is
chemistry,
related to this also.
then after chemistry, you'll start math.
Either maths or either physics. Maths, we have only one chapter at Drake.
No, chapter 24.
Yeah, it's okay. I know. We have only one chapter. We can stop it. We need to complete science first. That's why.
So your goal is to
You have
finish.
to-
Your goal is to finish by March, right?
Yeah.
March 15th or
That I have to check, beta. I can't say anything right now. Okay, guys. So done with the writing? David, lots of disturbance are coming from your mic, beta. Okay. Now, what is the uses? What are the uses of metal and non-metals? So you guys can read it. Who will read? Justin will read. Justin, please read this.
Uses of metals. Many metals like iron, copper, and aluminium are used to make containers. Metals like copper, aluminium, iron, and stainless steel are used to make utensils and frying pans. Ductile metals like copper and aluminium are used for making electrical wires. Steel ropes are used in cranes to lift heavy objects and making bridges.
Now, point number 3, they can ask that why the wires are made up of copper. Because they have highly conductivity power. They can conduct electricity easily. That's why the wires are made up of copper. It's a metal. Got it, guys? So you have to elaborate also. Like if it is 2 marks question, you can write in 1 or 2 lines, 2 lines or 2 3 lines. Okay. If it is 3 marks question, you have to use 5 lines to complete that. And if it is 5 marks question, then you have to write a paragraph. So you should know that okay, this is the marks. Then we have to elaborate it. Okay. Yeah. Malleable metals. Malleable metals like iron, aluminum are make iron sheets and all this. Why? Because it has a property of malleability. Okay. Alloy of different and non-metals are used for various purposes like stainless steel for making utensils. Non-metal, either read this.
Uses of nonmetals. Hydrogen is used in manufacturing of ammonia gas, which is further used in the manufacturing of urea, fertilizer. Hydrogen is a constituent of many industrial fuels like water gas, CO plus H2, and coal gas, H2 plus CH4. Silicon is used in making transistors, chips for computers, and photovoltaic cells. Silicon is used in steel industry to deoxidize steel, and it produces high quality corrosion resistant steel. Most of the phosphorus is used for making phosphoric acid, H4PO4, which is used in the manufacturing of phosphate fertilizers. White phosphorus as P4S3 is used in the match industry. Phosphates are added to the detergents as they help in the removal of dirt from soiled clothes. Sulfur is used in agriculture to control fungus and pests. Sulfur is used in the manufacturing of gunpowder, which is an intimate mixture of sulfur, charcoal, and potassium nitrate. Most of sulfur is converted into sulfuric acid, which is called the king of chemicals and is used to make a variety of other chemicals.
Perfect. Perfect. So with this note, we have completed this chapter. Do you have any problem in this chapter, guys?
Just one thing. Can we write the notes?
Yeah, you guys can write the notes, but at home. Okay. At home, you guys can write the uses. Okay. So.
Sir, we are at home already.
Okay. You are at home now. So it means that you need more homework, huh? Thank you, David.
No, sir, no, sir. No.
No. Thank you. Thank you, David. So because David requested that he is in home, so he wants more homework. So everyone can give thanks to
Please
David.
no.
No.
No, David. But David said he is in home. I didn't say anything.
Dad, he just said home. What does he didn't say more? Give me work. Please give us more work. He didn't say that.
He never said anything.
See, work is related to home. He's saying he's in home. He needs work.
Okay, I'll tell you a fun fact, sir.
Yeah.
David and Agatha are trying to rename Hardik sir into homework sir.
It was me, Edric.
My
It's
God.
you who just tried to rename. You just renamed him now.
Okay. So as David wants homework, so we'll give homework in the end of the class. Ira, you can write it down. So thank you, David. So now we will start a new chapter. Put a heading, chapter number 28, carbon and its compound. And this is good weightage chapter. Literally, I'm saying this is good weightage chapter for your exam. So guys, please pay attention in this chapter. Carbon and its compound. This is chapter name. I hope you can see this chapter. Now I will extract some pages. so that we can go with this chapter, go with the flow.
Go with the flow, rhyming.
Yes. Okay. Okay, guys. So this is carbon and its compound. So for information, everyone please pay attention. Miracle, turn on the camera. Okay, for information, carbon. Carbon has a atomic number as 6. Okay. So everyone please pay attention. I will give time to write. Okay. Now in K shell, 2 electrons will go. In L shell, 4 electrons will go. So it means that carbon outermost outermost shell has outermost shell has 4 electrons. Okay, 4 electrons. Okay, now carbon never goes for ionic bonding, for ionic bonding. So for knowing that ionic bonding, we need cation and anion. We learn that cations releases the electrons, anion take that electron, make bond. We learned with the respect of NaCl, like Na has atomic number 11, 2, 8, 1. Agatha, are you getting it? No.
I'm just wondering why
Mm.
carbon needs to go for ionic bond, needs to be stable. So why won't it go for ionic bond?
Yeah. So how many electrons are there in the outermost shell?
4.
So is it stable?
No, it needs 8.
8 electron. No? So that was I am saying. I was first introducing the ionic bonding. So ionic bonding first. Let me listen. Then I will give the answer of yours also. Okay. So ionic bonding like Na. Na has the atomic number 11. Now split it 2, 8, 1. David, are you there? Turn on the camera. David Miracle. Okay. 2, 8, 1. David. So Na will releases 1 electron. Yes or no? Okay. So now if I'll talk about the chlorine part. So David, what is the atomic number of chlorine? David.
So, 70.
Now split it in the form of shells. 2,
Uh, 287. Yeah.
it is getting wet in electron. That is released by.
Yeah, I can hear you.
Can you hear me now? Hello. No.
Now I can hear you, sir.
Let me check. Mic check.
1, 2, 3, 1, 2, 3.
Okay, so Na is releasing 1 electron and chlorine is getting 1 electron. That's make bond. It is called as ionic bond. Transfer of electron. So ionic bond is also called as transfer of electron. Now, now I wrote this statement that carbon never goes with the carbon never goes I said this that carbon never goes with the ionic bonding. Why? Why I said this? See, carbon has we know just now we know that carbon has an atomic number as 6. If I will divide it, it will go 2 in K shell and L in 4 shell. Now just run. How many like if carbon go for a cation part, if carbon if I will write if hashtag if carbon goes for cation. Now cation means just run lose of electron or gain of electron.
Loss.
Loss of electron. Correct. Okay. So if carbon will release all the 4 electrons from the L shell, so it will follow duet rule. Correct. Okay. Duet rule is the rule in which K shell should be the outermost shell and 2 electrons should be there. That is called as duet rule. So if carbon loses all the 4 electrons, so in K shell 2 electrons will be there and it is following the duet rule. That is correct. Ira, are you getting it? Yes or no? Agatha, I am giving answers of your question. Okay. So if carbon goes for a cation process, so it has 6 protons. It has 6 protons because atomic number is 6, so number of proton will be same as 6. Yes or no? Okay. But how many electrons should be there? But it has 2 electrons. Means what I'm trying to say, 6 protons are there and 2 electrons should be there. Now the problem in this case is the disturbance of the protons and electrons. Like I told you, the atom should be neutral also. But in this, the case is it has lot of proton and less electrons, which make it unstable, which is impossible. Did you understand? Yes or no? No, Adit didn't understand anything?
Sir,
Yeah.
Okay. So, when carbon goes for cation, it will become C4 plus.
Yeah, C4 plus, correct. Then
When
you have
carbon goes for anion, it will become C4 minus.
C4 minus. So, but the problem is here the protons and electrons have lot of variation, lot of differences, which is impossible for an atom to do it. Okay, it can do it till some limit, but carbon cannot do it because of lots of differences in the protons and electrons. So, because it has lot of differences in number of protons and number of electrons. That is why carbon can't go for cation. Okay, so we got a reason that because carbon lot of differences there in the protons and electron part, carbon cannot go for the cation part. Ira, did you understand, beta? No.
Wait, sir, I didn't understand like the 2 minus electron, like that part. Like why
See,
is that there?
if carbon will release all 4 electrons, how many electrons will be there then?
2. Oh,
Only 2 electrons will be there, no? And the protons will always remain in the nucleus. They never transfer. They remain in the nucleus. It means that it has 6 protons and 2 electrons.
okay. So the 2
So,
electrons are the electrons in the cation.
yeah.
Okay. Okay,
Okay.
sir.
Now, if for example, now Agatha will give me the answer. So, what is the atomic number of carbon? Atomic number is 6. Yes. So, in K shell 2 will go, in L shell 4 will go. Now, if carbon goes for a anionic part, if carbon goes for anion process. Now, what is anion process, Agatha?
Gain in electrons.
How many electrons he want?
2. No, wait. I mean 4. 4.
4 electrons. So he needs 4 electrons to become C4 minus. Okay, so now it has how many protons? It has 10 protons and sorry, 6 protons. Sorry. 6 protons. Proton will remain same. Proton will not change. So 6 protons and 10 electrons. Okay, so still it's a lot of differences that are there. 6 protons and 10 electrons. Lot of differences are there. So same reason, because it has a lot of differences and require a lot of energy to gain 4 electron, which is impossible for the real. Means in reality, it needs lot of energy to gain that 4 electrons. Okay, so which is impossible, nearly impossible. Okay, so these are the two reasons that carbon cannot be become cation. Neither carbon will become cation, neither the carbon will become anion. So that's why it never goes for the ionic bonding, because for ionic bonding you should be cation or anion. Yes, Agatha.
So are there other elements other than carbon which cannot form ionic bonds?
Other elements like silicon can also not go for the carbon.
So sir, minimum how much difference should there be between the protons and electrons to make the atom stable?
See, it depends on various factors. Okay, various factors like atomic size also. Okay,
Atomic what?
atomic size. Okay, it depends upon the like there are a lot of factors are there. If I will say according to the 11 term, if I will say, it depends on the like which table it is coming in S, P, D, which type of it's coming, periodic table. It depends on the number of electron distribution. So many factors are there. Okay, but 4 cannot be done in any stage. If 4 electrons are there in the outermost shell and 4 electrons needed, or 4 electrons should be donated, that is impossible, nearly impossible.
But if there's 3 electrons needed or should be gained?
So 3 electrons, it's possible at some stage. For example, aluminium can do this thing. Aluminium can releases 3 electrons. But if I will go down to the group, it's difficult.
Okay.
Okay. Everyone write it down this thing. Quickly write it down. Done with the writing part? Quickly write it down. David, are you getting this, beta? No. If you didn't understand, ask me, guys.
David God.
Edric, done? Done with the writing part? Edric,
Okay, sir, I'll do.
quickly
Sir.
write.
So, sir, for carbon outermost shell, it's 4 electrons, so it will never change.
Sorry, say it again.
Like for carbon outermost shell, it is 4 electrons, so it will never change.
It has 4 electrons. Now it has 2 ways to become cation or anion. Like for making a cation, he can donate all the 4 electrons. Now L shell will degrade, and in K shell, 2 electrons are there. It is following the duet rule. But losing so much electrons, okay, and there is a lot of difference in the protons and electrons then, because all 4 electrons are gone. So only 2 electrons are left and 6 protons are there. It's a lot of difference. And because it's lots of difference, it's unstable. Already it's unstable. Okay. Now, if carbon gets all the 4 electrons, becoming 8, the total number of electrons will become 10, and protons are 6, and it requires a lot of energy to be stable, which is impossible. Okay, so carbon cannot go for the cation also. Carbon go for the anion also.
Done, sir.
Done. Good. Done. Shall I go? Okay, I writing. Write it down, beta, aram se.
So what is written in the end? To gain 4 electrons, which is impossible for
For the for
I think he means in reality.
in reality, for in the real.
okay. Done, sir.
Okay, we'll read this. Who will read? Miracle will read. Yes, Miracle, go for it. Carbon.
Carbon is abundant in the universe, that is, sun, planets, and atmosphere of the Earth. It is present in carbonate rocks, that is, limestone, dolomite, marble, etc. It is also major constituent of fossil fuels such as coal, petroleum, and natural gas. It is present in the form of its compounds in all living organisms. Some such compounds are carbohydrates, proteins, fats, etc. In combination with oxygen, it occurs as carbon monoxide and carbon dioxide. You are quite quite familiar with these compounds. Our atmosphere also contains some pollutants arising from these carbon compounds. In in the structure of a carbon atom, there are 4 electrons in the second shell. The electronic configuration of a carbon is 2 and 4. To complete its octet, carbon requires 4 more electrons, but due to unfavorable energy considerations, it cannot gain 4 electrons by ion formation and hence attain the electronic configuration of neon. Due to the same reason, it is also not possible for carbon to lose these 4 electrons and attain the noble configuration of helium. However, it can form covalent bonds by sharing these 4 electrons.
So now for a revision, we should know that what is covalent bond. So covalent bond is the basically covalent bond is basically sharing of electron. Okay, sharing of electron. So we know that carbon will not go for the ionic bonding. Okay, but it will go for the covalent bonding, means it will share the electron. Okay, now how sharing the electron is there? For example, if I will take an example of methane gas. So everyone, you should know that methane formula is CH4. How many is there? CH4. Now C is basically carbon and H is for hydrogen. So if I will write the electronic configuration of carbon, it will be like 2 will go in K shell, in L it will go 4 shell. Yes or no? So the outermost shell has 4 electrons. And if I will go for the hydrogen, in K shell 1 electron is there, so the outermost shell has only 1 electron. If I will draw the structure of it, like C is there and 4 electrons are there. 1, 2, 3, 4. And how many hydrogen atoms are there? 4 is there. 4 hydrogen atoms are there. So I will make 4 hydrogen atom. 1, 2, 3, 4. Having one electrons each. Like this also has 1 electron. This also has 1 electron. This also has 1 electron, and this also has 1 electron. Got it? Yes
Yeah.
or no? Hydrogen has to do it. Why do it? Because in K shell 1 electron is there. So hydrogen can't transfer the electron. But what hydrogen will do? Hydrogen will say, okay, I will share your electron. So now this blue circle has 3 electrons, 2 electrons are there. Okay. In the same way, this blue circle is how many electrons? 2 electrons are there. In the same way, this blue circle has how many? 2 electrons are there. In this also blue circle has 2 electrons are there. Got it, everyone? No. So every hydrogen atom is now stable. But carbon needs 8 electron in the circle. So carbon will say, you guys took my electron for the sharing. I will take yours also. So I will make a circle like this. So now how many electrons are there in the in the red circle? In the red circle, how many electrons are there? 8. How? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, cha, cha, 3, 4, cha. I mean, sorry for 1, 2, 3, 4, 6, 7, 8. So 8 electrons are there. Okay, so 8 electrons, which says that it is also like octet rule is done. All carbon and hydrogen is correct. So the formula will be CH4 like this. This is how the compound CH4 is formed. Everyone got it? This is called as covalent bond. Write it down, then I will give you guys to make one covalent bond. Quickly.
So ionic bonding is the full transfer of electrons or full gaining of electrons.
Yeah, full transfer of electron. In the transfer, one will lose and another will gain, like that. This is called as ionic bonding. And covalent bonding is basically sharing of electron. Nobody will lose, nobody will gain. It will be shared. Got it? No.
Got it.
Done? Shall I use this?
Yes, sir. Oh.
Okay. So this is how okay. So now you guys have to make one compound and you should know the name also. The name is ammonia. Okay. Ammonia. And the formula is NH3. You guys try it. Try this compound, everyone. NH3. Okay. Now for a thing, you guys should know the atomic number and everything, but I am giving it like N atomic number is 5 and H has atomic number 1. So now split it, draw the diagram and show me. David, are you getting this? No. Try it, beta. I will help you.
Okay, sir.
Atomic number is 7. Sorry. My bad.
Yeah, 7.
Atomic number is 7, not 5. If you are not getting it, ask me, okay? I will draw it, but I want you guys to try it first. Then I will help you. Yes, Jacqueline.
Yeah, I will try it.
Done, sir.
Right, done.
Mhm.
Miracle, try it, beta. Like in K shell, 2 will be there. In L shell, 5 will be there because split. Now make N and make 5 electrons around it. And out of this, 3 hydrogen atoms will be attached to it. Like we made 4 carbon, na? Like that. Ira, you made it?
I'm making it, sir.
Hmm. David, where are you?
So I'm making it.
You are making it, and lots of homework waiting for you. One, two, cha cha cha. 3, 4, cha cha cha.
What is cha-cha-cha?
I don't know. Something coming in my mind. There's not.
Yeah.
Done? Agatha, you got it?
One. Yeah, got it.
David, you got it all? No. See, N shell, if I will distribute it, so it will in K shell, 2 will go, in L shell, 5 will go. Okay, so the last cell you have to represent. No matters how many electrons are there, we don't have to worry about that. Okay, and in H, H is the atomic number is K, so this is the last shell I have to make it. So if I will make it, so N has a 5 electrons. So I will show the 5 electrons 1, 2, 3, 4, and 5. Got it? Yes or no? And how many hydrogen atoms are there? 3 hydrogen atoms are there. So I have to draw 3 hydrogen atoms. 1, 2, and 3. And all 3 hydrogen atoms has 1 electrons with them. Okay. Now Miraculin, pay attention. Now this hydrogen atom needs how many electrons? This hydrogen atom, Miraculin.
One electron, sir.
So what it will do? It will take 1 electrons of the nitrogen, sharing.
Yeah.
In the same way, this hydrogen atoms, how many electrons?
One electron.
Like this. This hydrogen atom needs how many electrons? Electrons, like this. Okay. Now nitrogen needs how many electrons, Miraculin?
Uh,
Like 5 electrons he has. How many electrons needs
yeah.
more?
2.
No, no. 5 is there. He needs for the this octet 8 electrons.
I can't hear you properly, sir.
He has 5 electrons. Okay, and for the octet rule, he needs 3 electrons more. That is the correct way, no?
Yeah.
So, like all the hydrogen atoms are there, he will take 1 electrons from each, like that. Like this. You got it? So in blue circle, how
Okay.
many electrons are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons are there. Hence the compound is formed. It's gonna be like this.
Sir, is it okay if the two H is like above the N and below the N and one H is like here?
Can you show me?
Right, I'll just wait.
Yes, you guys make carbon dioxide. You guys make carbon dioxide. Try to make it. Yes, show me.
And when he does, he will drive you out completely. Tell the people
What's up?
Carbon dioxide.
Measure themselves as highly they engage by planning position and so Mitchell said this is what the report says about midnight. I will go to your regions. In the first one's region JP began from the first one. I will switch on the tone to the meeting. Towards had
Yes, Ira. What problem?
No, sir. Like oxide has to take two electrons from carbon, right?
Yes.
Okay, then it's fine.
Done, sir.
Done. Good. Rest. Anybody has problem? Jashwan? Done.
Yes, sir.
Okay. So if I will draw this, see, carbon has an atomic number of 6. So in K shell 2 will go, in L shell 4 will go. Yes. And if I will talk about oxygen, it has atomic number of 8. So in K shell 2 will go, in L shell 6 will go. So I have to represent it. Now carbon has 4 electrons. 1, 2, 3, 4. Yes, 4 electrons is there. And oxygen has 6 electrons. 1, 2, 3, 4, 5, 6. In the same way, 2 oxygen atoms are there. So I have to make 2 oxygen atoms. 1, 2, 3, 4, and then 5 and 6. So now I have to make the circle. So in the blue circles, like carbon, oxygen needs 2 electrons, not 1 electron. So this is 2 electrons. Okay. In the same way, this oxygen also needs 2 electrons. This will also take 2 electrons like this. So in the blue circles, how many electrons are there? 8 electrons are there, all satisfied. Now in the red circles will be 1, 2, 3, 4, 5, 6, and then 7, 8. Only 2 electrons will take. So hence the structure gonna be look like this, CO2. Like this. Got it, everyone? No.
So it's a little bit confusing. Can you
Yeah, tell me. What is the
like
confusion?
the diagram? The diagram is a little bit confusing.
See, it's nothing like it's not that much confusion. Okay, I will tell it. No problem. See, check. Now I draw the diagram. You have problem till now? Okay. Now this oxygen needs how many electrons? Like how many electrons are there? 1, 2, 3, 4, 5, 6. 6 electrons are there. How many electrons he wants?
2.
2 electrons. So he will take 2 like this of the carbon. Got it? So now in this
Yeah.
blue circle, how many electrons are there?
Yes.
How many electrons are there?
8.
8 electrons are there. Now this oxygen needs how many electrons?
2 electrons.
So he will take like this.
Mm.
Now in this, how many electrons are there?
8.
Done. Both the oxygens are satisfied. Now this carbon has 4 electrons with him. How many electrons he wants? He has 4 electrons with him. How many electrons he
Yeah.
wants to complete octet?
2, sir.
No, it's not 2. See, Octet means 8 electrons should be there.
Okay, 4 electrons.
4 electron. 4 electron means like he can take 2 electrons from this oxygen and 2
Yeah.
electrons from this oxygen. So he will
Okay.
make this. See on the code like this. So now in the red circle, how many electrons are there? 1, 2,
4 electrons.
5, 6, 7, 8. 8 electrons are there, no?
8 electrons.
So he will make the bond like this.
Okay, sir.
Everyone got it or not? Agatha didn't get anything. Yes, Agatha, ask
I
me.
got it. I got it.
Got it? Very good. So this is makes the bond. He always believe in sharing and caring. Okay, he's always believing sharing and caring. Okay, he never
Covalent
believe in.
bond?
Huh?
Who, the covalent bond or the ionic bond?
This is covalent, no? It's not transfer. It's sharing and caring. So it's a covalent bond. Okay. So this is how the carbon makes the bond. Now you guys have 4 minutes. Then come back. We will have a science class. Come back in 4 minutes. Come back.
Edric,
Yes,
is it hot in
Bangalore.
Bangalore? Is it hot in Bangalore?
I would say like in the like in the afternoon, like it gets a little hot in the month of January. So basically, like it's a little bit hot in Bangalore, and in the night it gets a little cold, like 13 degrees or so.
Oh, nice. Wait, 13 degrees in the night.
Yeah, 13. So.
Right now it's 27.
And in the daytime, it can get all the way up to like 30 or 29.
That's very hot.
Yeah. In summer, the average is 34, but this time they're saying it might go up to 36. And also, I have exam in April, so I don't think I mean, it'll be like too hard, like too hot, and like too hard to get to my exam center all the way in South Bangalore.
Oh, it's quite far.
Yeah, from Kalkeri to South Bangalore is like 30 or 40 kilometers. So in the hot sun, 30 or 40 kilometers. My mom is saying that the exam will be in the afternoon, but I want it to be in the morning.
Yeah, but the thing is, if it's in the morning, you'll have to get up a lot more earlier to reach there.
So like for secondary, it's saying that my mom is saying for secondary it's in the afternoon, but for 12th it's in the morning.
Oh. Wait, how much time would it take to reach to your exam center from your house?
My exam center is not like finalized, but it will take somewhere in South Bangalore. So it will be 30 kilometers will be like around 1 hour 20 minutes or 1.5 hours.
That's it? It's quite less compared to Mumbai.
So for you it takes like 2 hours to like 2.5 hours to reach the center.
Let me see. Okay, for let's see. Yeah, it takes me 34 minutes for like 8 kilometers.
Only 8? Only.
Yeah,
And
and it's
David,
showing that there's not much traffic. It's saying Google Maps. It's saying there's not much traffic, but it takes 34 minutes.
David, you know what? My PCP center is in North Bangalore. My PCP center is in North Bangalore. So not my exam center. My PCP class center. And that center, it's like in the morning, it takes like 36 minutes to get there. And
Wait, 36 minutes?
uh,
For
like
for
18
30.
kilometers, like 18 kilometers from my house to my PCP class center. And mostly on Saturdays, the classes are between morning 8:40 to 12, and basically after like 12, when I start from the PCP center, I reach home at 12:44. It takes 44. I mean, sorry.
To travel 18 kilometers in Mumbai, it would take like more than 1 hour. Maybe 1.5 hour to 2 hours it would take.
18 kilometers.
Yes.
He's joking me, but Bangalore,
The roads are bad, plus there's a lot of traffic.
like in the morning, there's not much traffic because Saturday, right? It's only Saturday, and on Saturdays there won't be schools, right? So basically, there's no traffic on Saturdays, so it only takes 36.
Yeah, I'll tell you what happened on Saturday. Okay, I was going for my football training. It is let's see how far it is.
Hey, you boys do know that there is another option to talk to each other instead of on the class?
Yeah, but it was a break. That's why we're talking.
Yeah,
Alex is back, by the way.
Oh.
We were speaking about topics, how the carbon and bonds are formed. We will learn about one property that is special about the carbon. It is called as catenation. Catenation. Now, carbon can form unlimited, like it's unlimited, make like bonds like this. Carbon can form unlimited bonds like this. Everyone, please pay attention, like this. This chain. Chain carbon has a property, special property called as catenation, in which carbon can make unlimited bonds like this.
So catenation is actually a process in which an element can make more than one bond, more
Yeah.
than 2 or 3 bonds.
Yeah, that is correct. But
Can make
catenation.
infinite bonds? Infinite bonds?
Yeah, carbon has a property of catenation in which it can make long chain. It can make long chain. And why carbon has this specialty? Because of its small size. Because of its
small size.
Now the same property has the silicon also. Silicon also have same property, but silicon doesn't have property like silicon cannot make bond till 40. Like 14, like 14 silicon can make bond, but after 14 it will break. But carbon has an infinity part. Yes, Jashan.
So the definition of catenation is something that can make infinite bonds with that carbon can make infinite bonds with each other.
Yeah, not infinity. Infinity. I'm just making focus not on infinity. I'm making focus on the forming of long chain. Carbon can make long chain like this.
So how about lithium? Lithium is also is small in size.
But lithium doesn't go for the covalent bonding, na?
Oh yeah, okay.
Lithium go for ionic bonding. But covalent bonding, catenation like carbon can go for make the long chain because of its small size. Everyone got it? Yes or no? Everyone write it down this thing. Quickly write it down this thing. Catenation, it can make long chain because of its small size. It's called as catenation. 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 Everyone got it? Because David messaged me again, so
No, sir,
I
I did not send a message. Sir, I did not send a message, sir.
okay. So Ira, you wrote this thing?
Sir becomes happy whenever he gives homework to us, like lot of work to us.
No,
Then
no,
he
no,
becomes
no.
like so happy.
Do you know what? I have seen a reel in a short in which there shows that teachers are more happy when students fail in the exam.
Aditya's new name is homework, sir.
Now, everyone done? Do you have any problem in this? No? Now, everyone, please pay attention. Now, this is important thing. Please pay attention. Now, we will learn new term called as allotropes.
Oh.
Now, allotropes means same element when they are made in different pressure and temperature. Same element is there. When they are made in different pressure and temperature, they will have different properties. Did you understand? No. Same element when they are made in different pressure and temperature in different pressure and temperature, they have different physical and chemical properties. They have different physical and chemical properties. So for example, everyone please pay attention. Please pay attention. So for example, we have different types of oh, I can't do this. So for example, if I will talk about the first one is diamond. Not diamond. First one is graphite. Now everyone please pay attention. I will give time to write. Now graphite is basically it's black in color. Very, very black in color. Okay. It's black in color. It's very flexible, like very flexible type material. Flexible type material. Okay. Material. Okay. And if I will talk about more about graphite, it has in graphite one carbon is attached to other 3 carbon. 2 other 3 carbon. 1 carbon is attached to 3 carbon. For example, if I will draw the structure of it, everyone please pay attention. Please pay attention. So this is the structure of basically the graphite. It has hexagonal shape. It has hexagonal layer. Okay, it has hexagonal layer. Now everyone please pay attention. Now each carbon atom is like see this in this board. If carbon has 4 electrons, it should has 4 bond with them. Okay, if carbon has 4 electrons, then 4 bond will form. We learn in the process of methane also. Like if I will check the methane, where is methane? Yeah, here's the methane. So carbon has 4 electrons and 4 lines are there. Did you understand? This is the important thing, because now after that I will not explain this, because all the chapter is based on this only. Like everyone please pay attention. Carbon should has 4 lines with them, representing all 4 electrons are bonded. Carbon will always have 4 electrons, 4 lines with them. Did you understand? If 4 lines are not there, if for example if 3 lines are there, then 1 electron should be free. Understood? If
Yes,
4 lines
sir.
and 1 electrons is free. Okay. If I will check about the carbon dioxide also, 1 line, 2 line, 3 line, 4 line. Carbon has 4 lines. Okay. Carbon should has 4 lines with them. Got it? Now if I will go in this, where is this? Yeah. So in this I told that 1 carbon is attached to 3 carbon only. It means that 1 electrons in each carbon is free, like this. In each carbon, 1 electron is free. Okay, so if I will pass an electric current into the graphite, then you know what will happen. This electric current is flow of electrons. So this electron will pass through this electron will pass, this electron will pass, this electron will pass, and like this we can conclude that graphite conduct electricity. Graphite conduct electricity. Why? Because in graphite, 1 carbon is attached to 3 carbon, leaving behind 1 electron as a free electron, and that free electrons, when comes in the influence of electric current, can flow there is a flow of electric current into it. Got it, guys? No. Edric, what are you doing?
Sir.
What happened?
Sir, nothing, sir.
He was lying down on the bed.
Yeah, it's looking like that you are lying down in the sky.
Oh my god, they're flying in the sky.
Yeah. Okay. So the question can come like this: how and why graphite conduct electricity? So the answer will be this, that in the graphite structure, one carbon is attached to the 3 carbon atoms, one electron remaining behind as a free, and that free electrons helps in the conduction of electricity. Everyone got it? Yes or no?
So always in graphite, there would be one free electron which would help conduct electricity.
Perfect. Edric, did you understand? No.
Yes, sir. Like here, like one electron is free, so electric current can flow, sir.
Electric current can flow. Perfect. Yes, Justin.
So for the question, what exactly are we supposed to write, sir? I didn't understand that part.
The question can become like this, that why graphite conduct electricity and how? So the answer will be like this, because of the structure of the graphite, it has hexagonal layer in which one carbon is bonded with 3 other carbon atoms. And if one carbon atom is attached to the 3 other carbon atoms, remaining behind one as a free electron. And when that one electron comes in the influence of electricity, it will flow. Hence, the electricity can, like graphite can conduct electricity. Okay. The influence of electricity, electrons will flow, and the electrons, if electrons will flow, the electricity will be there. Got it?
Yes, sir.
Okay. So now we were talking about allotropes, and allotropes, like graphite is made up of carbon only. Okay, this is made up of carbon only. And carbon, same carbon, not a different carbon. Same carbon is diamond also. Oh my god, diamond, the diamond, real diamond is made up of carbon. The real diamond is made up of carbon. Now, diamond is black in color. Yes, diamond is black in color, or what?
Crystal, transparent.
Diamond is silver in color, right?
Transparent. Transparent crystal.
Like transparent, it's shiny, it has luster. It is the hardest substance we learn in the non-metal and metal. It is the hardest substance. It's not flexible like graphite. So this is called as allotropes. Both have same element, carbon. But because of different pressure and temperature, diamond become like hardest substance and graphite become the flexible. So diamond, yeah.
I learned my earlier classes that carbon is made millions of years ago when some what was it? Yeah. Through fossil fuel, right? In fossil fuel.
Yeah.
So carbon is naturally in the atmosphere, but that one is fossil fuel. The fossil fuels were made from carbon only, right?
Yes, yes. We will learn this also. So diamond is transparent and lustrous, and it is the hardest substance. Hardest substance. And in this, all 4 bond are like all 4 like carbon. All 4 electrons are bonded. Means it doesn't have free electrons. Will it conduct electricity? No, diamond will not conduct any electricity. Why? Because all 4 electrons are bonded. Means all 4 lines are there. And if for all 4 lines are there, then it means that the electrons will not flow. Hence, the electricity will not be conducted. Did you understand? Yes or no? Yeah. So diamonds are generally lustrous. Deshaun. Okay, like diamond, when it is found in the state, it is lustrous. Okay, and the shiny part will be there when they will polish it and they will do different things. But diamonds are generally transparent and lustrous. Okay, so it won't conduct electricity. It won't conduct electricity. So because graphite and diamond are made in different temperature and different pressure, they both are made up of carbon only. They have both same father. which is carbon. But they behave totally different. So the question can come. The question can come that why diamond doesn't conduct electricity while the graphite conduct electricity. The answer of this is diamonds all electrons are bonded. There is no free electron, but in the graphite, one carbon is attached to the 3 carbon atoms, remaining behind one free electron, which helps in the conduction of the electricity. Did you understand? So, allotropes. So we will do till here only today. We did graphite and we did diamond. Tomorrow we'll do the coke, charcoal, and everything. Did you understand? Everyone, do you have any problem in this today? What we learned?
No, sir.
So one of you guys can take screenshot and you can write it down in your copy. And Adric, tomorrow I want your notes copy also. I will check your notes copy also. All the notes. Okay.
Should we also send our notes?
No, only Adric's. I want Adric's one. Okay, Adric. Can you hear me?
No, sir. I can't hear you.
Thank you. Okay. So take screenshot and then tomorrow we'll join in the same time and we'll try to complete this chapter by Friday, I believe.
So by Friday you'll complete this chapter and next Monday you'll start with maths.
Maths or physics, we'll check. Physics, what chapter we left?
Work and energy.
Work and energy is left. Oh. So we'll go for physics first.
Then after physics you'll do math, and then after the math you'll do bio.
So there's
Yeah.
technically only 2 more chapters in science. Work energy and hereditary.
23 also is there. Control coordination also is there.
Control and coordination.
That's also there.
So we have 3 chapters left. We can complete it. No problem. Okay then. So take screenshot if you guys want to write it down. Then tomorrow we'll meet on same time. Till then, bye. Have a nice day. Shall I erase this? The whiteboard? Okay. So till then, have a nice